What if this isn't the only universe? What if there are countless others, some almost identical to ours, others governed by completely different laws of physics? In one, Earth might never have formed. In another, you might be living a completely different life. This isn't just science fiction. It's a serious idea that some of the brightest physicists in the world consider possible. Today, we're exploring the best evidence that the multiverse could be real, from the strange predictions of quantum mechanics to the patterns imprinted in the cosmic microwave background, to black holes that might actually be gateways to new universes. Stick around until the end, because once we piece together all the evidence, you may find yourself questioning whether the universe you know is really the only one. When scientists talk about the multiverse, they don't mean just one simple idea. The term actually covers several possibilities. Physicist Max Tegmark famously divided the concept into 4 levels. At the most basic level, the multiverse could simply mean that space is infinite and beyond the limits of what we can see. There are regions of space that look very much like ours, perhaps even containing exact copies of us. A deeper version is the idea of bubble universes, where cosmic inflation produces countless separate universes, each with its own unique physical laws. Another possibility is the quantum version, known as the many worlds interpretation, where every quantum decision spawns new parallel realities. And finally, there is the most extreme possibility that even entirely different mathematical structures can generate realities of their own. For this video, we'll focus mainly on the first 3, because those are rooted in testable physics and offer the most intriguing evidence. Quantum mechanics, the science of the very small, has given us some of the strongest hints that reality might be far stranger than it appears. In the 1920s, physicists discovered that particles don't exist in one state until we look at them. Instead, they exist in a superposition, multiple states at once. Schrodinger's cat was created as a thought experiment to illustrate this bizarre idea. A cat trapped in a box, both alive and dead, until someone opens it. For decades, the standard explanation, known as the Copenhagen interpretation, said the act of measurement collapses this wave of possibilities into one outcome. But in 1957, Hugh Everett offered a revolutionary idea. What if the wave function never collapses at all? Instead, every possible outcome really happens, but each in a separate universe that branches away from our own. Many physicists take this idea seriously because the mathematics works beautifully without the need for mysterious collapse rules. Experiments continue to show quantum superposition in larger and larger systems, including molecules made of dozens of atoms. Even the principles behind quantum computers, being developed by companies like Google and IBM, are based on superpositions that can be understood naturally if many worlds is real. To some scientists, this isn't science fiction. It's simply the most straightforward reading of the equations. If quantum mechanics hints at multiple realities on the smallest scales, cosmic inflation suggests they may exist on the largest. In the early 1980s, physicist Alan Guth proposed inflation to solve deep puzzles about the Big Bang. For example, why does the universe look so uniform everywhere we look? Inflation offered the answer. In the first fraction of a second after the Big Bang, space expanded exponentially faster than the speed of light, stretching everything smooth. But inflation comes with a strange side effect. It doesn't stop everywhere at the same time. Instead, some regions finish inflating and form bubble universes, while other regions keep expanding, endlessly creating more bubbles. If this picture is right, our universe is just one bubble in a frothy sea of universes. Satellite observations of the cosmic microwave background by missions like WMAP and Planck confirmed many predictions of inflation, strengthening the case. And then there are anomalies, such as the so-called cold spot, an unusually large and chilly patch in the sky. Some scientists suggest it could even be a scar from a collision with another universe. As Andre Lind, one of the pioneers of inflation theory, has said, inflation almost inevitably produces a multiverse. Another clue that our universe may not be alone comes from the strange fact that the laws of physics seem exquisitely fine-tuned for life. The strength of gravity, the mass of the electron, the energy of the cosmological constant, all of these values sit within incredibly narrow ranges. Shift them slightly, and stars would never form. Chemistry would not function, and life as we know it would be impossible. Why should the universe be so perfectly balanced? There are three broad answers. Some people say it is pure luck. Others suggest it is by design. But the multiverse offers a third explanation. In an infinite ensemble of universes, each with different physical laws, it is inevitable that some will have the right conditions for life. We happen to live in one of those because we could not exist anywhere else. This reasoning, known as the anthropic principle, may feel unsatisfying to some, but it has real predictive power. In fact, Nobel Prize-winning physicist Steven Weinberg used it in the 1980s to estimate the cosmological constant before it was measured, and he turned out to be remarkably close to the actual value. That success lends credibility to the multiverse as an answer to fine-tuning. One of the most powerful windows into the early universe is the cosmic microwave background, or CMB. This faint afterglow of the Big Bang has been mapped in exquisite detail by satellites, showing us what the universe looked like just 380,000 years after it began. Most of it is smooth, exactly as inflation predicts, but there are anomalies that remain unexplained. Among the strangest is the cold spot, an area of the sky far larger and colder than our models suggest it should be. Other anomalies include the so-called axis of evil, where large-scale patterns in the CMB seem unusually aligned, and a hemispherical asymmetry, where one half of the sky looks statistically different from the other. Some cosmologists believe these could be evidence that our universe has interacted with others, much like soap bubbles colliding and leaving ripples where they touch. While these ideas remain controversial, they keep the multiverse firmly on the scientific table. If you want even stranger possibilities, look at black holes. These regions of space are so dense that nothing, not even light, can escape once it crosses the event horizon. Traditionally, we thought anything falling in would be crushed at a singularity. But quantum physics complicates the picture, because information is not supposed to be destroyed. So what happens to the information that disappears into a black hole? One radical idea is that black holes might be cosmic wombs, spawning new universes on the other side. Physicist Lee Smolin even proposed that universes evolve through this process, with those that produce more black holes creating more offspring. Over time, universes with the right physical constants for black hole formation would dominate, just as successful traits do in biological evolution. Even more mind-bending is the suggestion that our universe itself could have been born inside a black hole in another universe. If true, black holes are not just the end of matter. They may be the beginning of new realities. In the 1990s, theoretical physicist Juan Maldacena made a stunning discovery. A universe with gravity can be mathematically equivalent to a universe without gravity living on its boundary. This is called the holographic principle. It implies that our three-dimensional world might actually be a projection from two-dimensional information stored on a surface at the edge of the universe. If that sounds strange, it is. But it also opens the door to the idea that there could be countless other projections, each representing a different universe encoded on a different boundary. Experiments have even been designed to test aspects of this, such as searches for holographic noise in space-time tiny fluctuations that would indicate our reality is holographic in nature. While no definitive signal has been found, the very fact that such experiments are possible shows how seriously this is taken in physics. Parallel universes are not just abstract mathematics. Some researchers believe we might actually detect their influence. In 2014, scientists at Griffith University in Australia proposed a model called the Many Interacting Worlds hypothesis. Instead of universes existing completely separate, they suggested that parallel universes might interact with one another through subtle quantum forces. This means other universes could be brushing against ours in ways we might one day measure. And in 2019, a new wave of studies argued that the many worlds interpretation of quantum mechanics solves long-standing paradoxes more cleanly than traditional explanations. Even though no experiment has yet definitively proven these ideas, progress in quantum computing, entanglement experiments, and precision measurements is constantly pushing the boundary of what we can test. If parallel worlds exist, the technology of the coming decades may finally give us a way to glimpse their fingerprints. If the multiverse exists, the implications are almost beyond imagination. It would mean that there are infinite versions of us, living out every possible decision and every possible outcome. It would mean that our universe is not unique or special, but simply one bubble among countless others floating in a cosmic sea. The laws of physics themselves might not be universal at all, but merely the local rules of our particular bubble. For many, this is exhilarating. It suggests that reality is vaster and more mysterious than we can comprehend. For others, it is unsettling because it challenges the idea of meaning, destiny, and even finality. If other versions of us continue to exist in other worlds, then perhaps death is not the end, but just a transition to another branch of reality. As physicist Brian Greene once put it, our universe may be just one of countless others, like a snow globe in an infinite cosmic blizzard. So, is the multiverse real? We don't know yet. But quantum mechanics, cosmic inflation, black holes, fine-tuning, and cosmic background anomalies all point to a reality far larger and stranger than we ever imagined. Whether or not we ever prove it, the multiverse reminds us that reality is deeper and more mysterious than we can possibly comprehend. Thanks for watching. If you enjoyed this dive into the multiverse, hit like, subscribe, and share with someone who loves asking the big questions. Until next time, stay curious.